Hello everyone, welcome to ELO YouTube channel where we discuss organic chemistry in simplified terms. I will be discussing alkenes and their nomenclatures. Before I proceed to alkenes and their nomenclatures, I will first of all discuss some important features or characteristics of alkenes. The first is, alkenes, they have a general formula of CnH2n. For alkenes, the first member starts with carbon 2. If you substitute into the general equation, you have the first member to be C2H4, which corresponds to 18. The second member C3H6, which corresponds to propane. And the third member C4H8, which corresponds to butane. Another important characteristics or features of alkene is they are sp2 hybridized, which is the characteristics of double bond. Alkenes end with the suffix ene. Notable examples are the 18, the propane, and the butane. If you have a look at the names of this compound, you observe that they end with the suffix ene. Alkenes have the bond angle of 120 degrees, which is a very unique characteristics of all alkene family. So having discussed some important characteristics of alkene, let us now proceed to rules in naming an alkene. One of the most important rules of naming an alkane is first of all identify the parent chain. The parent chain is the longest chain containing the carbon-to-carbon double bond. We are going to use these two compounds, compound A and B, to illustrate how to identify the parent chain. In compound A, the parent chain is the longest carbon which contains a double bond, but in compound B, the parent chain is the longest carbon which does not contain the double bond. Because the parent chain in B doesn't contain the double bond, then B is not the right way to determine the parent chain, and A is the correct parent chain. Another step in rules in naming an alkane is to number the parent chain. In numbering the parent chain, we don't start from anywhere we like. We have to start numbering the parent chain with the carbon atom closest to the double bond. Let us consider these two examples below. Compound C and D. Compound C and D are identical compounds. What differentiates compound C from compound D is the method of numbering the parent compound. In the first example, we initially identified the parent compound, which contains the longest carbon with the double bond. In compound C, we started numbering from the carbon atom that is closest to the double bond, which gives the double bond position 1 in the parent chain. But in compound D, we didn't start numbering the parent chain from the carbon atom closer to the double bond. Rather, we started numbering from other carbon atom further away from the double bond. So in numbering the parent chain, we have to use the method or the example illustrated in compound C in such a way that the double bond gets the least position in the parent chain. So numbering of compound C is correct, while numbering of compound D is wrong. So after mastering how to number the parent chain, we can now proceed to the third step of naming an alkane. The third rule is any group or atom outside the parent chain is regarded as a substituent and its position indicated in the parent chain. Using compound C as an example, you observe that we have correctly determined the parent chain and also numbered the parent chain. Here, the next thing to do is to differentiate the substituent from the parent chain. If you examine this compound C closely, you observe that we have the substituent, which is a group outside the parent chain at position 3 of the parent chain, and that substituent is the propyl group. So in naming this compound, the name of substituent comes first, followed by the parent chain. Therefore, the right nomenclature of this compound is 3-propyl, because propyl is the substituent and is at position 3. Then hex 1N, because hex 1N is the parent chain. It is hex because the parent contains 6 carbon atoms. Then it is 1N because the parent chain is an alkane and the double bond is at position 1 in the parent chain. Another important rule we must observe in naming an alkane is when there are more than one double bond in the parent chain, we use the prefixes di, tri to denote the number of double bonds we have in the parent chain. Let us consider this example below. Compounds E and F are identical compounds. What accounts for the difference is the method of numbering. In compound E, we have the double bond in 1 and 3 positions, but in compound F, we have the double bond in 2 and 5 positions. So compound E is the right way to number this compound. So in naming this compound, we will observe that we have 2 double bonds at position 1 and position 3. Therefore, the right nomenclature of this compound is pent-1,3-diene. It is pent because the carbon atom or the parent chain contains 5 carbon atoms, and it is 1,3-diene because we have 2 double bonds at position 1 and position 3. So the right nomenclature of this compound is pent-1,3-diene and not pent-2,5-diene. Another important rule we must observe in naming an alkene is when the positions of the double bond are the same in the parent chain, then what we have to do is to extend to the substituent with the least position in the parent chain. Let us examine these examples below. Compounds G and H are identical compounds. What differentiates between compound G and H is still the method of numbering. In compound G, we observe that we have the substituent, the methyl group, at position 3. But in compound H, we observe that we have the substituent at position 2. So here now, what we account for the major difference in numbering is not the position of the double bond, because compound G and H have the same position of double bond, which is 1 and 3 positions in the parent chain. But in H, we have the substituent methyl group at position 2 of the parent compound. But in G, we have the substituent, the methyl group, at position 3 of the parent chain. Therefore, the correct nomenclature of this compound is 2-methyl-but-1,3-diene and not 3-methyl-but-1,3-diene. Another important rule we must observe in naming an alkene is the rule number 6, which says when we have more than one identical substituent in the parent chain, we use di, tri, and tetra to denote the number of identical substituents we have in the parent chain. Let us examine these examples below. In compound I, the correct nomenclature of compound I is 6,6-dimethyl-hept-2-ene. It is 6,6-dimethyl because we have 2 identical methyl groups at position 6 of the parent compound. Then the parent compound is hept-2-ene because the longest chain containing the double bond, which is the parent compound, is 7 and the double bond is at position 2. That is why this compound is named as 6,6-dimethyl-hept-2-ene. Compound J is named as 4,4-dibromo-pent-2-ene. It is 4,4 because we have the bromine as the substituent in the parent chain, and the 2 bromine are in position 4 of the parent chain. That is why it is 4,4-dibromo. Then the parent chain is pent-2-ene because the longest chain containing the double bond contains 5 carbon atoms, and the double bond is at position 2 of the parent chain. That is why we named compound J as 4,4-dibromo-pent-2-ene. Another important rule we must observe in naming an alkene is when there are more than one non-identical substituent in the parent chain, the substituents are arranged in an alphabetical order, starting with the substituent that comes first in the alphabetical letters. Example is illustrated in the compound below. The correct nomenclature of this compound illustrated below is 2-bromo-4,4-dimethyl-hex-1-ene. It is 2-bromo because the bromine substituent is at position 2 of the parent chain and B comes before M in the alphabetical order. That is why we wrote the bromine first. And it is 4,4-dimethyl because we have 2 identical methyl substituents at position 4 of the parent chain, and the parent chain is hex-1-ene. It is hex because the longest chain that contains the double bond contains 6 carbon atoms, and it is 1-ene because the double bond is at position 1 of the parent chain. For cyclic alkanes, the cyclic compound containing the double bond is the parent chain, while the group outside the cyclic compound is regarded as the substituent. Let us examine these examples below. For compound I, as an example, this compound is named as 3-ethyl cyclohexane. It is 3-ethyl because ethyl group is a substituent in the parent chain, which is a cyclic compound containing the double bond. It is 3-ethyl because the substituent is at position 3 of the parent chain. Then the parent compound is the cyclohexane because this is a 6-membered ring containing the double bond. Therefore, the correct nomenclature of this compound is 3-ethyl cyclohexane. For compound J is named as 5-bromo cyclohex 1,3-diene. It is 5-bromo because the substituent bromine is at position 5 in the parent chain. Then the parent compound is cyclohex 1,3-diene. It is cyclohex because the parent chain contains a 6-membered ring, and it is hex 1,3-diene because the double bonds in the parent chain are in position 1 and 3 of the parent chain. When we have similar groups on a double bond, we use the term cis if the groups are on the same side, and trans if the groups are on opposite side. Examples are illustrated in the compounds below. Compound K is named as trans 2,3-dichlorobutane. It is trans because the identical substituents chlorine are in opposite direction to each other, and it is 2,3-dichloro because we have the chlorine substituents at position 2 and 3 of the parent chain, and the parent chain is butane. It is but because we have the parent chain to contain 4 carbon atoms, and it is 2-ene because we have the double bond at position 2 of the parent chain. In compound L is named as cis 2,3-dichlorobutane. It is cis because the identical substituents are on the same side on the parent chain, and it is still 2,3-dichloro because we have the chlorine substituent at position 2 and 3 of the parent chain. These two compounds are called stereoisomers because they are identical. What actually matters is the orientation of their substituent in space. In the trans, their orientation are in the opposite direction, that is the substituent, but in cis, the identical substituents are in the same direction in space. The trans and cis nomenclature of alkane are only restricted to identical substituents that are connected to the double bond. But when the groups on the double bond are not identical, we use a more comprehensive E/Z term for the nomenclature of the alkane. Let us consider these two examples below. The first step in naming compound M is to assign priority between the carbon-to-carbon double bond, which is at position 2 and position 3 of the parent chain. In position 2, we observe 2 bonds attached to carbon atom, which are the methyl group and the hydrogen. The methyl group takes first priority over hydrogen because of the higher molecular mass of the methyl group. Then in carbon number 3, the methyl group takes lower priority over the other bulky group, while the bulky group is assigned priority 1. So in E nomenclature, if the highest priority groups attached to carbon number 2 and 3 are in opposite direction, then it is E. But if the highest priority substituents attached to carbon number 2 and 3 are in the same direction, then it is Z. Therefore, compound M is named as E because the highest prioritized group in carbon atom 2 and 3 are opposite to each other. That is why it is called E. Then it is 3,5-dimethyl because we have the 2 methyl groups are at position 3 and position 5 of the parent chain, which is the hex that contains 6 carbon atom. It is 2-ene because the double bond is at position 2 of the parent chain. Thank you so much for listening to my video. Please like, subscribe and share. If you have any question, you can leave your questions in the comment section. Thank you.